What's up, guys? Welcome back to our channel. So, in the last video, which is basically a few weeks ago, we did some trigonometry, remember the basics. So, let's continue with that. And and last video, even if you remember, we did some examples using where we solve, for the sides, even if an angle is given. Now, we're gonna just reverse that procedure and we're gonna do the opposite. So, well, we know this is a right triangle, A, B, C. And we have learned that let this be X, Y, and Z. And we know that let's consider angle C. Sine of angle C is opposite over hypotenuse, X over Z. Cosine of angle C is going to be Y over Z. Tangent of C is going to be X over Y. And basically, if you remember these three, the other three are going to be so easy, as I said. And cosecant of C actually is going to be Z over X, opposite of sine. And secant of C, which is opposite of cosine, is going to be Z over Y. And cotangent of C is going to be opposite of tan, Y over X. So these are the basic stuff if you remember. So we're going to use this to solve the reverse case. Okay, so let's consider let's consider a right triangle again with A, B, C, right? So first let's kind of assume the sides already. So we can find the angle. Last time we solved for the sides when the angle was given. Now we solve for the angle when the sides are given. So let's just say AB. Angle B is 90 degrees, of course. AB is 3. AB is 3, BC is 4. And you need to solve and given that this angle is kind of like 60, looks like a 60. So they ask like, let's not just take this 4 already. Okay, let's make it some other case. Because these are called Pythagorean triplets. So they're kind of, I could remember some of those easy. So let's just take like, let's just take 10, okay? Let's just take this side as 10, AC as 10. And they ask us to, okay. Let's just say this is 6 and this is 10. So they ask us to find, angle C. Okay? So now what we need to do is, if you consider this angle, these both are kind of related as sine, Sine of angle C is going to be 6 over 10. Now, we need to, reverse since we need to find the angle, this is called, inverse. Angle C is going to be sine inverse of 6 over 10. I took a hard example at first, so I'll get to the easy ones. Angle C is going to be sine inverse. And now you may be confused between inverse, which is not you think as 1 over sine is equal to sine of -1. This is false. So this is actually kind of a different inverse where we need to assume, where we do that for calculating the angle. So let me just grab my calculator. Okay, So now let me do sine inverse of sine inverse of 6 over 10, and that gave me 36.8 degrees. 36.8 degrees. Alright. So not a good, not a good perfect example, I should say. Yeah, but yeah, you solve it in this procedure. But if they ask for this angle, but they give for the same measure, what you need to do is just if you know the angles and property of a triangle, it is 180 degrees. The three angles add up to 180. We know this is 90. We're gonna add it to 36.8 degrees. Plus, let's just assume angle A as angle x degrees, and that's gonna give us 180, right? So just find x. 180 minus 90 plus 36 in parentheses. What does that give us? That's gonna give me 53.2. Yeah, that's it. Okay. So problems are gonna be like this. The basic from the basics. So next, what we're gonna discuss is, the same thing. I mean, especially if you're doing trigonometry, like basics. If you need to revise the Pythagorean triplets first, like the Pythagorean theorem, if you remember. You see, if you have basic stuff like 3, 4, you should automatically assume tell answer as AC as 5, like that. And the same course with 6, 8, and 10. If this is 6, this is 8, it's going to be 10 for sure in a right triangle. Oh, that's a very Pythagorean. They're called as Pythagorean triplets, since they don't change in a right triangle. The measures, if this is 6 and this is 8, it's going to be 10 for sure. So they're kind of fixed. So yeah. Now let me do some basic example, as I said. So if this is 1, I can do the same example. If this is 1 and this is 2, of course this is going to be, let's ignore BC for this time. So we have to calculate angle C. Okay. Now let's assume the relationship. How does angle C gives us the ratio between these two sides? So you should remember sine of angle C is going to give us 1 over 2. Now I took this example because I can remember the angle C measure in my head, because when I used to do trigonometry in my school, I used to remember these values before I had a test. So C gives us sine inverse of 1/2. Better write the 1/2 in parentheses, so it's going to be clear. So now if you type in, I know it's going to be 30 degrees. Even if you type in sine inverse of 1/2, 30 degrees, yeah. Actually, since this is a acute triangle, it should be only 30 degrees, but there are many other possibilities. It certainly cannot be only 30 degrees, because we have this thing called unit circle, where we have a circle full of angles and measures which have specific points, like coordinate points at different, which touches the circle at different points. So actually, in terms of the unit circle, we add a value, with plus 180k. K is a constant, and if you put any, let's assume k is like 1 or 2, 1. let's assume 2. Sine of 390. Sine of 390. That's gonna give you again 30. I mean, wait. Yeah, that's gonna give you 1/2. Yeah. Okay. So that's this basic examples of the vice versa of the examples that I discussed in the before video. So if you liked it, please like, share, and subscribe to our channel. And yeah, we'll keep posting videos like this. And the next one, I mean the next coming one, which is soon. So I'll be getting into unit circle as I mentioned before, and that's kind of a hard topic. I mean, it's easy to understand first, but as it goes on, it's going to be hard. So yeah, it's circular trigonometry. That's kind of hard than this one. Okay, guys, thank you.